Hi, everyone. Thank you for joining us for today's special live session, Visual Component Testing with Cypress and Applitools. We have two very distinguished speakers with us today, and I'll take a moment to intro them. So first up is Gleb Bahmutov, VP of Engineering at Cypress.io. Gleb is a JavaScript ninja, image processing expert, and software quality fanatic. During the day, he makes the web a better place as VP of Engineering at Cypress.io, and at night, he fights software bugs and blogs about it. He is also a Microsoft MVP for open source software. Second up is Gil Tayar, Senior Architect and Evangelist at Applitools. Gil has over 30 years of software development experience, and before he joined Applitools, he co-founded Web College and worked on various big projects at Wix. In addition, Gil is a sought-after public speaker and frequently talks at notable international conferences about test automation and software development. Gil is also a faculty member at Test Automation University, and his course, Introduction to Cypress, is available on the Test Automation University website, so please be sure to check that out, obviously after our session. So without any further ado, I will turn this over now to Gleb.
Thank you, Adi. It's my pleasure to be a guest on this webinar. Gil, how are you?
Great. Finally, it's been a while, virtually, but that's okay these days.
I will take virtually over nothing. Not many people realize that I share 50% of letters in my first name with Gil, which, in my book counts for a lot.
Nice, like that.
Okay, so what we will cover in this webinar? We'll first show an example of end-to-end visual test. We will use Cypress and Applitools. But then I'll talk about something else. So recently we implemented component testing. In this case, I'll show component testing for React, which are not like, terminal tests. Instead, we'll see everything we are testing live in a browser, and we'll use the same visual assertions from Applitools with component tests. We'll finish with tips and tricks where Gil and I will share some of the, things that we learned that will help you write good visual tests. And then definitely, like Adi said, we'll finish our webinar answering your questions. So, Gil, are you ready?
I'm ready, Gleb. Take it away.
Okay, so if you're like me, you like to play Sudoku once in a while. So I saw this nice little application that implements a Sudoku game. I didn't write this application, but I like its style and how you play, and there are lots of modes. And you can find the source code at my GitHub repository. I forked it for this webinar. You can play it live, so I have a live URL. So not only it's nice to play in full desktop mode, this application implements nice responsive styles. So I can play it on my phone, on a tablet, and it changes its layout depending on screen resolution. So really highly recommend playing this version of Sudoku. So imagine you have this application, and then you want to maybe implement another feature. Maybe you want to implement online play. So what happens? Well, you change some code and you push it to production. And I don't know about you, but what I really, really want when I push something to production is not to be woken up at late at night by a PagerDuty call saying the customers cannot play the game. And I know, Gil, you have another word for this, right? Where you want your production code to work, but you're afraid.
Yep, I think fear.
Yes.
In last year, fear is the mind killer, and to kill our fear of pushing to production, we need to kill our fear of one's own code, which I call ego programmophobia. It's the fear of one's own code, and testing is the ability to remove that fear.
Exactly. So let's write the first task. In this case, it's Cypress. I'm not going to explain what Cypress is. For that, you should go to Test Automation U and just watch Gil's excellent free Cypress course. But this is the end-to-end test written Cypress. We set the viewport resolution if we want to, in this case, 300 pixels wide. And then we visit the URL, and URL could be localhost, could be production URL. We're visiting the actual URL in the browser. And then our test will make sure that there are, game cells field, that it contains the timer and the difficulty level. So this is how it looks when you run it inside Cypress. The good thing, but you can see every element, every command right there in Cypress time traveling debugger. So all our assertions, right? But check, for example, that there are 45 game cells filled, that there is status timer, right? Status of difficulty selector for a game. They're functional assertions. They just check that that element is present and visible, right, on the page, but they don't check how it looks. So imagine I come in and I personally don't write much CSS. So I think that this position relative is unnecessary, and I just comment it out and I push the code. So what does it do? And you can see this particular pull request yourself. So what will visually change? Will it stay the same? Can I push it, or should I be afraid? So if I change the CSS or styling or class or layout, will the application look right? Because it's pretty stylish right now. So as a human, I probably can look at the app and I can say, yeah, it still looks right. The computer cannot say if it looks right. The computers don't have an idea of what right is. So I have to do it manually. But the problem is that I have to check the desktop resolution. I'll have to check my game, how it looks on a tablet, and I'll have to check how it looks on a mobile screen. So every time I have to do this visual, this checks manually, it just quickly becomes too much work, right? So what can we do to make sure that CSS change doesn't break our application? Gil, you want to explain this section?
Yep. What we need to do is basically what we call visual regression testing, or visual testing for short. Visual regression testing is the ability to know that nothing has changed, and if something has changed, to know what has changed, so that we can either accept the change as the new baseline or reject it and say, well, we found a bug, let's fix the bug. So how do we do that? And we'll be using, obviously, Applitools eyes, and Applitools has a Cypress plugin. Let's first, install the Cypress plugin, and the way we do that is we go into our repository and we do npm install as a dev, the plugin, which is at applitools/iCypress. Cypress needs some initialization so that the plugin can be like glued into Cypress and make it nicer. So you run npx eyes setup, and eyes setup just puts in whatever is necessary into the various Cypress configurations. Now we're ready. The first thing we need to do, and this is define before each test what we need to we need to open eyes, which is start a session or start a test. And eyes open, you need to specify the app name, which will show nicely we'll see in the dashboard shortly, and we'll specify all the browsers that we want to see screenshots for. Okay, we have, in this case, Gleb talked about the 3 responsive widths, which are 1024, 600, and 450 in the case of this application. So we certainly want to see the application in these widths and heights. But remember that not all browsers are different, so we would really like to see the screenshot. We would like to see the application as it is on Firefox, let's say Safari, and horror of horrors, if we need to support IE11, then yes, IE11. Applitools also supports, Applitools goes a long way to supporting as many browsers as you need. So not only do we support like various widths, but also various browsers. And if you want iOS devices like iPhone and iPad, then you can specify them here. And if you want what we call Chrome device emulation, just like you have in the Chrome DevTools, you can specify it here, specify which width and height you want, and pixel density, and all kinds of things. So you can basically support any Android device in existence, because all Android devices are basically run Chrome. So you have a width of browser supports Safari, Firefox, IE11, iOS, and Android. So this is the preliminary. We define how we want, which screenshots we want to take. Next, what we do is in the test, we want to specify some visual tests. Remember those functional tests that we have? We have the checking that it has 45 length and that the status time in that and the difficulty is easy. But to do a visual test, we do eyes check window, which is the eyes plugin added to the SCI object, and we specify a name for the screenshot. We call it a tag. What this will do is it will take a screenshot of the page and generate screenshots for all the various browsers that we had in the eyes open. Okay, now notice that you don't need all those browsers on your local machine. And why is that? Because we're not really taking a screenshot in the SCI.eyes check window. What we're actually doing is taking what we call a DOM snapshot. What is a DOM snapshot? A DOM snapshot is what we do is we go to the DOM, go to the page, and remember Cypress is really crazy and fast about this because the DOM is right next to our test code. So we take all the DOM and we take all the CSS and the SVGs and the fonts and the images, and probably I forgot one or two kinds of resources, everything that is needed for this page, and we upload it to the Applitools visual grid. Once those are uploaded, we can basically recreate the page in any width we want and in any browser or device that we want. And those devices and browsers don't need to run on your machine because they run on the Applitools visual grid. And this is the result. You can see here in the Applitools test manager, which is the UI where you can see the results of the test. You can see, in this case, Chrome 85 running 1024 by 768, and you can see the screenshot as Applitools generated it. But remember, we took a long list of browsers. You can see here the top three. You can see the different resolutions. So you'll get all the screenshots in the various browsers. And there's this little video showing you all the different screenshots. So you can see that it really did take various screenshots and the responsive design works. And the interesting thing is this works amazingly well because responsive design relies on CSS. Because there's no JavaScript involved and everything is CSS, we can recreate the page in the various resolutions and take screenshots for that. Yep.
The interesting thing, right? So we completely avoiding this question, does it look right? Because only humans can answer it, but it takes time. And computers cannot do that. What we'll do instead now, but we can accurately recreate DOM snapshots and have images, is that we'll say, does it look the same, right? Because we'll store that image, and every time we generate a new image when we run test again, then we just can compare the baseline image to the new one. And guess what? Humans are very bad at comparing images. That's why you give kids a game, right? Find 10 differences into images, because we can't. It takes forever and we cannot accurately do it. But computers are really good at comparing pixel by pixel images. They're fast. They always find all the differences. So let's go back to our CSS change. I just commented out position relative, and now Applitools actually shows me. So Gil, can you explain what we're seeing here?
Sure. What we're seeing here is all the changes that CSS did. Notice that I have, and we'll deal with that in a second. Notice that I have, because the data in the Sudoku board is random, we can see all the numbers have changed, but we can, and in a second, we'll mask those changes. But Applitools immediately recognizes those changes for what they are as diffs between the current test and the baseline image. But notice that we're not even, well, we're not doing pixel by pixel. We're actually much smarter than that. We're using AI to compare the page as a human would in terms of visual differences and not pixel by pixel. Because we've noticed that when we do pixel by pixel, it's the little changes, even from browser. Let's say we're using Chrome 84 and now we're using Chrome 85. You will notice little differences that have nothing to do with your, it's like font aliasing things or they're rendering the bitmap a little bit differently. All those little changes that you won't notice and really aren't very important, Applitools will ignore them. We have some really interesting computer vision and AI algorithms that ignore those changes. But if you continue on, we even have more. What we can do, because we're uploading the CSS and the HTML, when you see a change and you say, what caused that change? And you click on it using what we call root cause analysis, you will immediately get the CSS or the HTML that caused this change because it's diffing the HTML and the CSS. So you can, if it's a bug, you can immediately know what the bug is and what the CSS that caused it was, which is amazing for troubleshooting.
Really, it's my favorite feature. I'm amazed how it works.
Me too.
Well,
me too. But remember the visual differences, like were a lot of visual differences because the board was bad, or the board changes from run to run. What we want to do is mask them. We want to ignore the whole board. So what we could put an ignore region on that board and say just totally ignore it. That's possible, but it's not good, because then if we ignore the table, maybe there aren't any numbers in it, or it's mangled, or there aren't any rows or cells. What we want to do is we want to tell Applitools, please check the layout of the board and ignore the data in it. This is what we call layout mode. And if you can go back for a sec, what we can say, please, you see the selector game __ board, which is the selector for the board, ignore that layout region. And if you go to the next slide, you'll see that Applitools has ignored that region. It's not totally ignoring it. It's checking the layout. It's checking that the layout is exactly the same, but if the text is different, it will ignore those textual changes. That is another feature that we have, which is crazy important for dynamic data applications. And once we mask that, suddenly we see the real diffs. You can see there the diffs are for the text that we changed the CSS for, and it's ignoring all the others. And we can see that the text is in different places because responsive width means that the layout is different for each page.
So here are things that make visual testing in end-to-end test difficult. But the data could be random, like this game. The clocks and the timers make creating pixel by pixel identical images different. Animations and transitions can make images different. So Applitools works hard. It actually disables animation and transition. So I will not talk about it, but I will talk about dynamic data next. So one thing that you notice in our test, it was nice end-to-end test, but loaded the whole page in our browser and did visual regression testing. But we could not play the game because the game was dynamic, the board is random, so we could not do it. And we didn't exercise any of the components that actually compose the game, right? Our components inside the game could have multiple states, and it's hard to really exercise every component because it's hard to reach it through end-to-end tests. So let's see what we can do about it. First of all, our application is built from React components. If we look at the game board and then we look at our source files, we can kind of see what the components are: the footer, the header, the status section, the numbers, and so on, the app. If we have, for example, React DevTools, we can highlight on the page every component, because modern apps are usually made out of some kind of components. Our top level just says render app component on a page. The app has the game component surrounded by Sudoku provider, which keeps all the data in a React application. And the game component kind of brings all of the components together, sets everything up, sets up all the event listeners for props, and now the game can start. If we look at the individual component, in order for test it, we have to look at what it receives as inputs. So inside our game, there is this numbers components. It just allows you to pick a number to insert into the cell. So what does the parent do? The parent creates this component and passes on click number prop. So every time you click a number, that prop fires. The actual selected number, the stuff that you see in blue, comes from a context provider. That's the top level element that keeps all the data. If the number you're rendering matches number selected, then you add a class. And then the props just passes the click handler. So in a sense, our component as inputs takes the props, the context, and user clicks, right? That's another source of inputs. So if we really want to test this component, we have to feed it different props, different contexts, and user clicks, and see how the DOM looks and if the property was called in response to the click. And we want to check how that component looks depending on the data and how different components behave in response to the user interactions. For example, we have the status and there are different toggles. So we really want to kind of send click events to that component and see that it looks correctly. So this is what we've done at Cypress. We decided Cypress is a great way to write end-to-end tests, but it'd be nice to be able to test components. So for React, you add one adapter that we have written for React. Then you initialize it, you put these lines into your Cypress code to hook everything up correctly, and you enable it. Right now, it's experimental component testing feature, but it's not going anywhere. We will actually make it part of a core. So here's the difference between end-to-end test and a component test. You import mount command from Cypress React Unit Test. It's similar to Enzyme, React Testing Library. You just import that mount, and you import your component. And then instead of say visit URL, you say mount that component. That's it. That's the whole thing. After that, you can use all Cypress commands. So in this case, how does it look? This is what it does. It takes our component numbers, mounts it where usually the application would be, and we see how component renders. And we see all the commands from Cypress right there. So right now,
and Gleb, this is an amazing feature. I mean, up to now, it was let's use Cypress for end-to-end tests, and we'll use like Jest or JSDOM with Mocha for component testing. But JSDOM is limited because it's not really a browser; it's just a simulation of a browser. And now suddenly we can do everything in Cypress with both, the flexibility because we have a real browser and the speed because Cypress is so quick because it runs in the browser. This is an amazing feature.
Thank you, Gil. And like Gil, very astutely noticed, we can see the component, but it doesn't look real, right? It doesn't look correct. Well, why? Because in our application, we use CSS, right? We have the styles. So we import styles just like we import in a game. And then it looks like this all of a sudden. Still not 100% correct, because in order for styles to be applied correctly, we have to surround our component numbers with the right markup. And then the classes from CSS will be applied correctly. Think of a component as a mini web application. So when we mount, all of a sudden we see the component, how it looks in a real game. If you want to exercise props and see how, in response to the user click, the component sends back a message, you just pass a stub, all standard Cypress command, and then you click on a number using Cypress, which goes through real DOM, and then you check that component was clicked, and you see everything in Cypress command log. If you want to see how the component renders selected number, you surround that component with context provider, pass number 4, make sure that that number has the expected class, and now you see it, and you see it's blue. But now we can go one step further, because this is a real mini. Yes, Gil?
No, one step further, sorry.
Because this is a real browser, just like end-to-end test, guess what?
Yeah, we can do visual component testing. And remember, what Gleb showed in the previous slides were basically functional tests. You're checking that the component functions correctly. I mean, Gleb could have removed that import of the CSS and the functional test would still have passed. It
Yes.
would have looked like shit, but it would still have passed. Visual testing enables you to say, okay, now I know that the component works correctly. Now I want to see that it looks correctly, right? So, but it's the same tools. We do a mount. Can you go back one?
Yeah.
We do a mount just like in the previous test, and we can actually combine the two. You don't have to separate visual and functional. Okay, we do a mount. Because Cypress is so fast, sometimes if we do an eyes check window immediately, the component won't render. So we use Cypress itself to ensure that the component is rendered by using should have length 9. So it basically uses Cypress's auto retry feature to ensure that the component really is rendered on the screen. And then we do the eyes check window, and what we will get is component testing of that specific component. And this is great for design systems where you have like these tens of components that everybody in your company uses. You don't want to test them in the application, you want to test them separately. So what you want to do is use Cypress component testing, test them functionally and visually, so that when everybody in your company uses them, you know they'll be okay. Yeah, sorry, just a sec. Again, if we want to do a visual test of the selected number, we do just like before. We wrap it with this context provider, give it the data, and then do the eyes check window. But notice that if you're doing that, you don't really need that sci.contains should have class, because you're doing the test anyway using Applitools, and you see the screenshot and you check that the selected number is blue, etc., etc., etc. And let's see how that looks in Applitools.
And Gil always kind of
yeah,
it shows that you check that selected number is 4 and none of other numbers are green, for example.
Oh, right. I told you that when we did the rehearsal, because remember that the sci.contains check that the number is 4. Did it check that all the other numbers aren't blue or green? That it doesn't. Well, the beauty of visual testing is that it's also functional testing, and it checks everything, even things you didn't think about. And we can see that in the component test in the Applitools test manager, in the various browsers and the various widths. Okay, can you continue?
I just took videos of Applitools dashboard. Is amazing, has so many screens, so many ways to actually analyze the screenshots, see if they have changed, if something fails. It's really an amazing tool.
Thank you. And Applet, I mean, because remember what we did, we took the DOM snapshots, and the screenshots are being rendered not on your computer, but on the visual grid as a software as a service. What we can do is we can take all those screenshots in parallel. So if, for example, one test generates 100 screenshots or 50 screenshots, those 50 will be rendered in parallel. So it doesn't matter how many screenshots you have in the test, it'll take roughly the same amount of time, which is 30 seconds, 20 seconds, depending on the load and where you are in the world. So it's pretty fast to work interactively. And if you look, Gleb, because he's a JavaScript ninja, implemented a nice way so that if you don't want to skip those tests during development, you can set an environment variable, and boom, those sci.eyes check window will be skipped, and you just run functional tests. You can look at it in the repository. It's very neat.
That's right. So I definitely can vouch that Applitools Cloud is fast enough if you want to work locally and immediately see the results. You can skip the screenshots and only do the visual regression testing on your CI. But because it's real browser, you can still see how the DOM looked at that moment. Okay, so we tested numbers component, one of those low-level components, it's nice that it works, but can we test the components higher up the hierarchy? Can we take the whole game component and use component testing? Can we do this? Instead of site visit, can we mount component and do eyes check window? So we can, right?
Yeah, and that's the beauty of component testing. Again, think of one app. This is a one-page app, but think of an app that has like 10 pages. You can test each page separately without running the whole app, which takes time and is a bit flaky, blah blah blah. This is amazing for front-end testing, because it enables you to do that while mocking the back end and testing only one specific thing without running everything that is needed to run the whole app.
Yeah, and unfortunately, in this case, just like end-to-end test, we will hit the same problem. Every time a test runs, there is a new random board, and like Gil showed, we can ignore it, but if we ignore something, there might be problems there. So component testing allows us to solve this problem easily. So here's what happens. We look at the source code of a game. App.js component uses game.js component. Game.js component, how does it generate a board? Well, it imports this method, getUniqueSudoku, from another module. And when it calls it, and it gets new arrays. One array is the starting array. So, every time you see a 0, it's an empty cell. And then it also gets solved array. So this is complete array at the end of the game. So we can save those files as pictures, as JSON files. And inside the component test, we can do the following. We can import them just like normal JSON imports. Then we can import that module, solver unique Sudoku. That's what game will use later to generate the board. And before we mount our component, we can stop an import and a method on an import. So every time the game now calls getUniqueSudoku, it will get our fixture file. So it will get the same data. Then guess what? We'll get the same board every time in our component test. You see, empty, empty, 9. This board is now deterministic. And when we, for example, have this game, well, when now can actually play the game, we can make one move and run eyes check window and target one move. And this is how it will look, because we actually solved the randomness in our component testing by stubbing a method.
And this kind of mocking and stubbing and playing around with this is possible only in component tests,
yes,
or more easily in component tests, because you're basically running the application code and just using the application code, so you can stub whatever you like. This is wonderful.
I can exactly. If I were running end-to-end test against the production build, there is no way. Well, there is a way, but it's really hard and requires changes to the code. But there is no way to reach inside the application and stop something. But now we can, right? And we can look at how this board looks after one move in different resolutions, different browsers, right? It's just beautiful. And guess what? If we can play one move, we might as well play the whole game. In this case, I initialize the board, so there's only one empty cell. I take a visual screenshot, but it looks like that. So I just have to solve the top left corner, and I solve it because I know the answer, right? And I take another visual snapshot. And guess what? My game, when you finish the board, looks like this. It shows an overlay, you solved it. And the beauty of end-to-end tests is that when you run them in Cypress, it's just the same as end-to-end. You can see every command, you can see where you clicked, how the game changed in response. You can see you win the game overlay. You can see that if you click it, it actually starts the game again. The component test is pretty much end-to-end test, but only at the component level and not at URL level. And the beauty, Applitools has all the screenshots from the test. So this is how the game looks when you almost finish it, right? Finish it and then start a new one. This is how it looks on desktop. This is how it looks on a mobile phone. And no matter what CSS changes we do, layout changes, we'll never break the game accidentally. We can only change it purposefully and knowing what the consequences of our code push will be for the user. Okay, so that was the component testing. A couple of tricks for your visual testing. Like Gil said, like we showed in our examples, always use an assertion before the visual snapshot command. Every command in Cypress is asynchronous under the hood. They will retry. So if you want to make sure that your component test has an accurate and consistent image, make sure that the DOM has rendered, that it has updated after a user event, right? So in this case, make sure that there are 9 status numbers before you do eyes check window. When we won the game, before we took that last screenshot, we made sure that the overlay is now visible, and then we took the screenshot.
But you need to make sure that there's one functional assertion just to make sure that the page is already rendered, but don't add more functional assertions. They're unnecessary, and why? Because your eyes check window checks everything on the page, including whatever. So one functional assertion just to check that the page is rendered, and then the eyes check window will check everything.
Exactly. You can actually remove parts of your test because the visual assertion is so effective because it checks the whole thing. But by the way, we use eyes check window and we check the whole page, but Applitools can also check individual selector. So you can actually compare parts of a page and not necessarily. But as you can see with component testing, right, we want to take a whole look and not just parse it. One thing, eyes check window has a lot of parameters, so you want to configure IntelliSense right away. Even if you use JavaScript and don't do anything else, in modern code editors, you can add this line with reference types. Applitools eyes Cypress comes with TypeScript definition, so as soon as you add that line, all your commands, eyes check window, all of a sudden will have help and IntelliSense, and will tell you what all the options are. So really, really useful. And you saw in every example, right? We use tags so that we can easily find the screenshots, and we can understand if it's a single screenshot in a test or several screenshots, one after another, and you can see kind of a progression of a test through visual screenshots.
And don't forget, you're not testing only on one resolution. Your design is probably responsive. Check it on different widths and check it on different browsers. Just don't go overboard. Like everything in testing, if you go overboard and do too much, that's also not good. Try and minimize the number of resolutions to those that will be needed because there's a change in the responsive design. And in terms of browsers, you know what your users use, so use those.
Well, I would advise to use as many different browsers and devices because you pay to Applitools per screenshot, right, Gil? So the more you use, the more you pay. So it actually works out very well.
Thank you, Gleb. Thank you.
But it's nice. It's nice of you to actually say only use the necessary resolutions, and also
we're there for the customer. What's good for them?
Exactly. So at the last slide, before we go to questions and answers, traditionally end-to-end tests visit the URL and then verifies the whole deploy application works, the same way as the user would use the app. So what's the difference with component testing? The component test concentrates on a component, right? Individual unit of code and all the children component that it uses. And then it verifies that it works in a variety of situations, different props, different data, different user actions, all the things that component is supposed to work in as opposed to end-to-end test. But despite the differences, both of these types of tests will use real browsers, not the emulations, will have all the user interactions as realistic as possible, all the clicks, selects, and so on. And both types of tests can use functional assertions, check out if element exists, check if it has a class, check if class goes away, and visual assertions. And that's the key point. But if you combine functional and visual assertions in both types of tests, then you can sleep better at night because you will not accidentally break something and make your application unusable or look bad.
Here, here.
Okay, so I want to thank Gil for helping with this presentation and with visual tests. You can find Gil and me on Twitter, right? I love communicating with users and answering questions. The slides are public. You can find all the code that we have shown in the repository. You can actually see the pull request and so on. We do have a couple of guides at Cypress for visual testing and component testing. And for everything Applitools related, just go to applitools.com. We have lots of documentation for Cypress and our framework and test runners. So highly recommend doing that. So are we ready to go to questions and answers, Adi?
Okay, I've got the questions. Hopefully you've got the answers. And oh my God, I forgot how much fun it is to have you both for a joint webinar. It has been too long, Gil. You were right.
No.
So yeah, first question. It's regarding slide 7, Gleb. If you want to go back to it, and then we can go back to the thank you slide. So we were asked, is this only relevant for CSS? Sometimes we have JavaScript code that changes the style based on the screen size and other form factors. How can we support that?
Obviously, if your JavaScript changes the style or the HTML changes, then that's also relevant, not a problem. Visual grids have a limitation in that if your DOM snapshot, meaning the HTML and the CSS and all the other resources are uploaded, and that is not sufficient to do the responsive design, and it needs like some JavaScript that is handled with the on-resize, then that is something that the visual grid has limitations. In this case, Applitools has the ability to run local screenshots, and we have an upcoming feature where we resize to all the viewports that you want, so that the DOM in the local browser, so that the DOM snapshots will be correctly rendered by your JavaScript. So we have the visual grid limitation, but it's going to be lifted like in the coming month or two, so that should not be a problem.
Okay, next question. So Gleb, this one was when you were talking about React. So someone asked, can this work with Vue and not just React?
Absolutely. So if we have Cypress React unit test, we have Cypress Vue unit test, we have Cypress Angular unit test, Cypress Svelte unit test. So every major framework, we have a library for that. Right. So just substitute your framework name right here, and we probably have it already. If not, let me know. It's easy to write an adapter for any framework.
Next question. Can I give it to you?
Absolutely, absolutely.
Wonderful. Is it possible to mock or control side effects in component testing? If a component uses use effect and updates the state, can we control it or mock it?
Pretty much, yes. So if you look at Cypress React unit test, there are almost like 100 different tests showing how to do things. While writing this library, it was important for me to go beyond every test runner currently available, like Enzyme, React Testing Library. So I looked at all their documentation, all their guides, all the tutorials that other people have written for React, for example, and I tried to create the same example using Cypress React unit test. You can mock, you can stub, you can control the network, the clock, pretty much anything you can do with other test runners. Cypress has a way of mocking it as well.
would I need an extra config with Ionic apps that have Ionic mode iOS, for instance, for specific element display?
Oh, no idea. Gleb? I've never used Ionic.
I have no idea, honestly. Probably write to us, open maybe a GitHub issue with some code, and we'll see. Right now, I have no idea.
Well, I did promise questions, and I said that we might have answers. That's we were very clear. So next questions. I see that we have multiple dashboards, one for Applitools and one for Cypress. Is there any way to integrate those into one dashboard?
That's a great question, an interesting one. We do have GitHub and BitKeeper, and I think GitLab integration when you're doing a pull request and it has Applitools in it. The Cypress dashboard we haven't yet integrated into.
Right, and I can add that we would love to integrate more. And there is a way when you run Cypress tests to get our URL back, so you can add it anywhere and click on it and go to our site. Right now, I would say Applitools dashboard is really, really good for looking at visual regression test results, right? Like really good. That's its focus. And for Cypress dashboard, the focus is different, right? It's for parallelizing your tests, finding flaky tests. So we try to concentrate on both aspects of a dashboard and test history. So for a foreseeable future, I would say you would need two different dashboards, unfortunately, in order for you to use visual tests and Cypress dashboard.
Okay, I hope I get this next question correctly. Can we do component testing with Redux state?
Absolutely. So if you go to Cypress React unit test, you will see Redux tests. I grabbed Redux example repository, ran their tests with Cypress. Absolutely. The good thing is that the code runs right inside the spec file. So you can get a reference to the Redux store, for example, pass it to the component, and then control it from the test itself and see how the component changes. You can do DOM events like clicks, typings, checkboxes, and then check the Redux store, and if a component updates it correctly. Absolutely, Redux store is probably the easiest thing to check inside your component test.
Sorry. Yeah.
Same goes for MobX. If some of you are using MobX, that'll probably work too.
It should. And just check out our README. We have all examples that are already included in the repository. We have example apps like how to test React scripts or Next.js app inside the repository. And we have probably like 20 external repositories, but actually show like a bigger project or some external tool where we show how to use Cypress React Unit just with that tool.
How can we define browsers for mobile devices, for various mobile devices?
We have two options. One is you specify an iOS device. You just specify its name, iPhone X, iPhone 8, iPad 2nd generation, iPad 3rd generation. You have an enum for that, or you can just specify the name. That's for iOS. For Android, we don't yet have Android real devices, but we do have Chrome device simulation, which is for all practical purpose exactly the same. In this case, you just specify that mobile is true. You specify the width and the height and the device scale factor. You can get those from the internet for that device. And we have a large list of predefined devices like Samsung this and OnePlus that and all the others, where you don't need to specify the width and the height and device scale factor. If that device that you want isn't there, you can specify the parameters by yourself. Oh, and what I didn't say, you can do it in landscape and in portrait.
Nice.
Okay, another interesting question about the Sudoku board that you showed before. Like obviously, when we were showing it and doing a bit of gamification here, when we're ignoring the values inside the Sudoku board, the numbers, are the various text labels associated with the controls are also being ignored, or can you control that differently?
I'm not sure exactly what the various labels mean, but it's basically ignoring the text inside that Sudoku board and just checking that the layout is the same from the baseline and the checkpoint. It's actually doing a combination of visual testing that layout and using the DOM that was uploaded to figure out whether it's the same layout and the same thing, if you want.
Is it possible to write tests and share them in multiple projects?
I would say yes. But I would suggest that you write tests and have a test live close to the code it's testing. So for example, if you have a shared library of component, well, put those component tests right next to the component. So every time you change the component source, you run its tests. If you have end-to-end tests for application that imports that library of components, I suggest that you write end-to-end tests for that particular application. So every time you change something in an application, the tests have to be changed, or at least we verify that the application still works. If you have components and you want to test them inside the app source code, maybe to make sure that the components behave according to what the app requires, just put a component test there as well, right? If you have a situation where you have to share the tests in several repositories, maybe send me a note. I want to see what your situation is, because I would have a test to be as close to a component as possible.
Yep, totally agree.
How easy it is to trigger these sorts of test cases? We're talking about a visual component test cases from a CI/CD pipeline with something like Jenkins.
As easy as any tests are. So we suggest that you keep your tests with your source code, right? So they live in the same repository. So I think that every commit that you push should trigger tests, right, on Jenkins, on CI. If you have a pull request, that should trigger probably the tests as well, to make sure that you're not accidentally merging code that will break everything, right? And you don't merge the broken code. So every time you commit, it should probably run tests and should verify. Now, some people have a large repositories where they have, for example, a bunch of libs and apps, and in that case, they don't want to trigger the test for everything if they have, a source code change for one specific component. But then it depends on your monorepo setup, on how you find which tests to run. In that case, it's up to you to set up it accurately, so you don't actually run tests for everything unrelated to your source code change. But for me, run the test as for everything on every commit. If they run too long, use our Cypress dashboard parallelization to run tests in parallel. Applitools is super fast. It actually parallelizes all your screenshot generation and comparison, so everything will be fast. But test more rather than too little.
And I'd like to know that because you're testing browsers, unfortunately, if you want, your app runs in the browser, so you need to run a browser to test that. To run a browser in a CI environment used to be very, very, very difficult. Today, it's easier because most CI configurations support headless browsers like Chrome, okay? Right. So Chrome is great, no problem today. The problem is Safari, IE11, iOS, etc., etc. Yeah. But if you're using the Applitools Visual Grid, you don't need all those browsers, because you run those tests on Chrome and then get the screenshots for all the various different browsers that run on the grid, the Applitools grid.
Yes, yes.
Okay, so unfortunately, and I mean it from the bottom of my heart, unfortunately, that's all the time that we have for today. I'm going to ask Gleb just to move all the way to the last slide so you'll have all the information. Of course, don't worry, I'm going to send the slides over to you alongside the recording. So I got a few questions about that. You can rest assured you will receive all the assets. So I want to thank everyone that joined us today for this live session. And of course, I want to thank our amazing speakers, Gleb and Gil. So again, one quick reminder before I let them say their goodbyes. The link to the recording with the slides will be emailed to you by end of day Tuesday. And I do hope to see you all at our next event. So thank you very much.
Thank you everyone for listening. Thank you, Gil, for doing this webinar with me. And to everyone, stay safe and happy testing.
Thank you, Gleb. Thank you, Adi, and thank you everyone for listening. It was a lot of fun.